And software is deterministic. It's a box. You put something in and you get the same thing out for the most part, right? What we're doing now with AI is we're making the software fuzzy, right? We're matching this, and that's kind of cool, but also there's some issues behind that. So this is AI, okay? It's this amorphous thing, and it can do some really cool things. And now what we're doing is we're trying to build more and more on top of it, right? Everybody's using Cloud Code to build something. Some people are trying to set up harnesses so like a feature request automatically gets, a pull request or whatever, right? Without anybody like stepping in. And all of those things can have like some pretty catastrophic results for a specific reason. So when we're working with code, everything is interfaces. Somebody's talking to us, whether it be an API, a front end, whatever, and we're talking to other services, databases, Stripe, whatever, and all of these interfaces create nodes. And if anybody's like super familiar with graph theory, that means that you're creating a system that has nodes in which they can all affect each other, and that inherently creates power loss. So when something goes wrong, it can go catastrophically wrong, right? So what we want to do is bound these problems in some sort of way, right? At the root problem, just like day to day when you're using LLMs, I'm sure everybody's seen this. The LLM will hallucinate features, APIs, whatever. It's sometimes painful too, like you'll have to follow up and say, hey, you didn't do this thing, this isn't working how I told you to do it. I see that every single day. And then you'll push something to production, it'll cause an issue, and you'll have to come back to it. Like, why didn't you do it right the first time? Like, I figured out the problem, but I wasn't aware of it the first time. So, and this blast radius gets bigger and bigger with power loss. And so I'm sure everybody's seen like the big outages in the last few months, AWS going down, Microsoft, Cloudflare, all of these things. I'm going to take a guess and say that was caused by not verifying what was going through their systems. So what's the solution? The solution is adding some deterministic loops to the system, adding some verification. So coupling non-deterministic LLMs with deterministic validation to ground them in some sort of reality, right? Something we can verify. And multi-layer feedback loops mean, we should shoot for that because it means we can move faster as engineers. So, awesome talk. This talk's awesome. Anybody seen it? Raise their hands. The Victor invented on principle? No? We got one. Okay. It's awesome. If you should watch it if you have a chance, but we're just going to cover a few seconds. So this is old. Okay. It is not updating. Do I need to share again? There we go. Okay, so you guys didn't see my last few slides. Does that make more sense now? Okay, power laws, bounding boxes, all right, verification. All right, so we're here. So this is sick, honestly. Old talk, like 15 years ago at some conference. He's just giving a little demo. Video games are great for demos, right? So he's creating this little Mario game, and he's saying, like, what I want to do is play with some of these variables, and I want this end result. I want the little Mario player to be able to bounce off the shell and to make it to the star, or make it into this hole based off of the gravity variable. So normally, if you'd be making this, like, how would you test this, right? You'd go through, you'd tweak the variable a little bit, try it again, tweak it a little bit more, try it again. And so that's what he's showing here. But he adds a little bit layer so that the feedback loop gets significantly smaller. It updates in real time. Okay, so that's step one. So he's just dragging this variable the gravity or the bounce or whatever you want to call it, the velocity is adjusting. And so he's gonna play with that. Okay, maybe that's a little bit too much. Like, what if I want the character to fall in that little hole? Well, what if I could rewind and play back what I just did? Wouldn't that be cool, right? Let's play it. I don't have to actually time it perfectly every single time I test it. I can play it back. That would be a cool tool, right? So he goes through and he's playing with these variables, and now he's saying, okay, now I want it to bounce off of the shell and maybe go into this hole. Same problem, right? Like, okay, even if I have these tools to make it quicker, how, like I still have to, it's somewhat manual still. I still have to figure these things out. And so in software, same thing, not as fun to look at, right? If we're working in the back end or whatever, we see things like that all the time. We're trying to figure out the domain as we're like exploring it. And let's see, right here, he's gonna show my favorite part. Let's go, okay, it's only a few seconds away. Okay, so then he adds another layer of feedback. So now instead of having to play with it every single time, he sees all the potential outcomes of what could happen based off of what he just did, right? Like the timing he just had with a specific gravity he just had. But now he sees, if he drags that variable, you can see the result in real time without having to try to time it perfectly every single time, okay? So, for me, huge, right? Like seeing this is like, okay, I want that, right? Like, wouldn't it be sick to have that all the time whenever we're working with something, have the feedback instantly as we can explore it. Again, things are fuzzy, the problems we're solving are fuzzy, let's explore them. Let's explore that fuzzy space and, bound it. So a few interesting lines from here. But Victor says, creators need an immediate connection to what they're creating, experiment freely, try ideas before you commit to them, discover the domain and experience by playing with it. Without a loop, a world of ideas will just never be, okay? So that's the first thing. So let's talk about how we can implement that in the day-to-day working with agents. So what does that look like? There's layers of loops, okay? Some small ones, some fast ones are like linters and type checkers. So maybe this is not super known, but most tools like Claude Code, Open Code, or Pi have hooks that you can tie into, so that anytime the agent edits anything, it runs something in the background. Updates the file, runs the linter, formatter, whatever, runs the type check, whatever, right? Again, this only works if it's fast, so it should be fast and asynchronous. So if it's going to be really slow, it probably doesn't make sense to be like part of these like small loops that anytime a line of code gets edited, it gets run. But there's other layers, okay? So there's the human in the loop. Okay, that's another small loop. If anybody's familiar, there's like this set of skills from this guy named Matt Pocock. One of my favorites, this prototype skill, and just creates a few wildly different variations of a UI that you can experiment with. And we might play with that in a little bit. And something I'm going to show later is Tidewave. Some of you might be familiar with Cloud Design, but also a pencil and paper. Fantastic way to get feedback right away. So another loop that you can add is you can add your own, right? So these are ideas, but part of like being the human in the loop is adding your own verifications. Like, you understand your problem. What verifications exist that you could do? What could help you make that feedback loop smaller? What do you do manually that you could automate? Let's figure that out. Another small loop. So this one's really cool, and it's specific to, it comes by default in some languages and tooling, but you can add it to anything. So in Elixir, my favorite programming language, there is a tool, an MCP server called Tidewave. all it does is present an MCP, like some tools that the agent can use to evaluate arbitrary code against your dev server that's currently running. Not only that, but it can target specific, like stateful instances of things in your server as well. It's really cool. That's just possible in Elixir by default. Super cool. But you can do this in any language. So all you do is, if you're working with the backend, you create an endpoint. This endpoint then is just a dev endpoint, and you just make it evaluate any arbitrary code. So you can do this in Python, and you can do this in Node. And again, in dev, right? Don't ship that to prod. And the idea is that you can test assumptions real time with immediate state feedback. So going back to how the models are trained, they're trained like this in a longer period of time. So if you can present this to the agents as a tool immediately, they'll iterate and test their work faster. So I'll show a demo in a little bit, but that means that feedback loop of you telling, hey, agent, do this thing, and it implementing it and it checking its work is way faster. It doesn't have to write a test suite. It doesn't even have to write a test. It just writes, a couple lines of code calling a function in your code base. It makes that quicker. All right, and then a larger loop. So this is, it was great to have before agents, and I think it's even more important now, but adding Git hooks and tests in CI. So when you're going through and you're shipping a feature, when you land a commit, there's tools like one's called left hook, and anytime you run git commit, it'll run a command, and if the agent's running it, it'll see, hey, my code has this error because of this thing that I added. Right? You don't have to tell it. It's going to see it on its own. So super important. There's no reason not to have them anymore. Big fan of testing nowadays. And we have the massive loops. So did anybody see this? The Next.js Liberation Day? I thought it was hilarious. So for those that haven't seen it, Cloudflare basically created a fork of Next.js, but it doesn't run TurboPack or whatever Next.js normally runs. It runs Vite. And it solves the biggest complaint that people have with Next.js is that it's extremely slow. It's a really slow dev server. It's a pain. And I love the drama between the Triangle Man and the Cloud Man. It's great. So, but that was just one example. And that's only possible because there's test suites that you can run. So everything you just talked about at the smaller scale, you can do at a big scale. You can say, hey, I have this test suite. I need to rewrite it in Rust, and it needs to all pass. Go for it. And you just lightly supervise and see what it does. So they did that with Bun and Rust. So it was originally at Zig, and I think they went back to Zig. I think it was a failure. I don't know. Obviously, this Next.js version. And then I talked to the Posthog guys, and they also had an interesting idea, which is to, if I remember correctly, it was to speak the protocol that DuckDB speaks over Postgres, meaning that anybody could communicate with the DuckDB database over Postgres protocol. So I might have gotten that backwards, but you're seeing these really ambitious goals that might have taken years, months to do, lots of money, and you can do them in maybe a week. So I think that's so cool. And the validator is really the only thing you need. So if the agent receives this feedback constantly, and if you make that feedback automatic, it'll eventually get there, right? If it's possible, and if it has the tools to do that. So I'm going to show a little example. So here I have this same slide deck.
Wi-Fi slower.
Is it?
It's the Wi-Fi.
Okay. There we go. Okay. So same slide deck, and here I'm using a tool called Tidewave, and it's awesome. It's great. You can use it for lots of languages, but and there's other versions of tools that do something similar. It's just the one I'm familiar with. But let's show a little demo. So this is just a to-do list little thing, and it is backed by a server and database. So one thing I can have it do is I can say create a to-do item in that list. Let's see if it finds it. All right, so it did it in the backend. So it called, I was going to show this later, but it did it in the backend first. So let's refresh. Let's scroll to the bottom. And we see this item here. Okay, so this one it did in the backend, and it called that here. So now let's tell it to do it. Let's enable vision mode. Add one using vision mode. Let's allow everything. All right, so now it's going to run some script on the front end. It's going through and clicking, and it added an item, okay? So that's a pretty quick feedback loop, right? This is saved into the database. It's there. Again, you can do this directly from Cloud Code. So I can go in here, and I can open up Claude. I'll say create an item in the to-do list using tide wave eval. And it'll go through and do that. It'll take a second. It'll explore this repository. But again, we can expand the ambition. This is pretty small. This is very basic. Like, let's say we do something a little bit more complicated. Let's say, hey, let's see if I can do a dictation. It's being a little slow. Add another slide after the to-do list. Make it a snake game and use vision mode. I'm still in it. It shows me still in the Zoom meeting.
Yes, I
There's another tab up top, it looks like.
thank you.
There we go. Okay. And then vision mode enabled. Okay. And we'll go through and do this. So again, the idea here is to show, hey, if it has access to the tools, if it can evaluate what it's doing against something, whether it be a screenshot, whether it be a test suite, or like some arbitrary code it's executing, it's going to go through and get closer to the goal, and it's going to do so faster as long as that goal is fast, right? As long as that validation is fast. So let's allow all, let's bypass these permissions. All right, and it'll go through and do this, and it'll take a bit. So it's just creating some JavaScript. We'll see it in a sec. It needs to add the slide. And just to clarify, this tidewave tool, it's using Cloud Code under the hood. It's not special. It's just a couple of other extra tools on top of Cloud Code. That's really all it is. All right. So it's starting to create it.
And you said it was called tidal wave?
Tide wave.
Tide wave.
Tide wave. Yeah. It works in Next.js too if you use that. If that's your taste. All right, it's going through, and it played it. It tested it really quickly, and it got a game over. Game logic works, the sync moved right. And, we're seeing results. And we can continue from this, right? Like, we can say something like, now that it's working, I don't know, back it with real-time events in the database and publish those events so that we see them in the front end. Okay, so and this is kind of putting together lots of those different layers. It's checking, evaluating things in the back end, it's checking them in the front end, and it's going through and doing that. So we'll see how it goes. But the goal here is to show a couple of things. One is there's no reason not to verify every single step, like add things that verify where it makes sense, right? There's code is cheap. You can just ask Claude to create, these arbitrary endpoints for you, these validation things, these Git hooks, these Claude hooks, and there's no reason to not attempt something ambitious that you just leave running overnight. We just talked about these loops. Like, there's no reason you can't stack loops on top of each other that create a bigger loop. Anybody's familiar with like the Ralph loop? There's good tools for that as well. So same sort of things. And yeah, I think that the future of where it's going is that we are going to get more ambitious in places where it makes sense, and we're also going to get, ideally, I think that the higher quality results are going to win out. So whether that be, software engineering or whatever, in the end, people will like those things more, and I think that'll become more popular. So I say, yeah, that's what I say, and go out and make something interesting. So that's it. Thank you. Is there any questions? Yeah.
So, a lot of people put all these skills and extra stuff all around, and they use a lot more tokens. Mm-hmm. As tokens are getting more expensive and a lot of these subsidies are kind of dying, is that going to change?
It's a great question. So there's, it's interesting because the economics of that for the frontier labs are interesting because they're not only they're profitable if you're only taking into account inference, but then if you take into account all the training, then they're completely unprofitable, right? But there's this other side where there's companies that only focus on the inference side. So there's this one called Fireworks, I believe, and they provide models like Kimi or GML, Z, all of these things, and they're cheap. DeepSeek, all of these things, they're cheap. The reason is because they're not working on the training. It's just pure inference. So I think
More of a Ralph with the move.
yeah. So all of those things are cheap, and on that side, and so maybe the cheap is at least I think for the foreseeable future, the cheap models are only 6 months behind, and so yes, maybe the frontier labs will get more expensive, but at the same time, these other ones are going to get less expensive, and they're only 6 months behind. So I don't know where that leads, but I think it's already you can use these open source models. They work. You can't run them on your computer in a useful way. I mean, you can run them. They're not going to be great. But yeah, I'm not super worried about that.
It's interesting because I think you're going to start seeing some companies manage their budgets a little bit better. Or as many devs have earned the whole year's budget,
Yeah, no, that's a good point. And the economics are a little bit different there, right? Because like a Claude Code subscription is like very subsidized, whereas like tokens just in inference aren't, and that's what these budgets are in. And also, it's also kind of like a leadership thing. Like the leaders are saying, burn as many tokens as you can, and
they have been.
yeah, and they have been. So they're going to. They're not going to necessarily do something useful with them, but they're going to. So, yeah.
You were saying like the post-testing for the models? What exactly are they like testing them against? Is it just like prior model tests?
They're testing them against like open source things. So like a good example, I'm not saying this is the exact one that they do, but like a good example that I would do is like, hey, randomly change something in the Linux kernel and say, hey, model, this, it doesn't compile for the, here's the error, fix it. And then they, fine-tune the model based off of that. The weights in the model themselves adjust based off of the reinforcement learning there.
So are like the devs
No, well, there is some of that too, but most of this is automated, right? So they're creating like maybe test suites of, lots of open source projects and telling Claude to go through and do something, and when it gets it right, it says good boy, and when it gets wrong, it says bad boy. So that's pretty much it. Yeah.
How do you account for when you're creating all these tests and running it through that the agent doesn't change the test so that it passes?
Yeah, that's a good question. I've heard of that happening. It doesn't happen super often with when I'm coding. I think that part of that has to do with that some languages are treated differently by the LLMs. So there's a funny study that came out like a month ago, maybe a couple of months ago, where they evaluated different programming languages against what kind of results they get from LLMs. Like somebody says, hey, do this thing in this language, and it'll go through and do it. And they evaluated the results, and guess what? Like JavaScript was near the bottom because there's a lot of bad JavaScript code, whereas for Elixir it was near the top. So another reason to use Elixir. So at least I haven't seen it, but I think that's just like another verification step that you could do, right? So like let's say like that you assume that your test suite is always increasing and the model has like a habit of, like if it does something wrong, it just deletes the test. Then you put a verification in there, in your Git CI that says if the number of tests go down, like throw up a big red flag to check that the model did something wrong. So.
Yeah, they could add 5 and remove 3.
What's that?
If it added 5 and removed 3, then you're still in trouble.
Yeah, that's true. Yeah. So, and I think that's interesting because like it goes back to the engineering discipline is just, I think it's just changing. It's not, I don't think it's disappearing. It's definitely tough for like junior level, but it's changing. So the engineering work is still there, and the engineering work is now kind of going towards like this validation layer and testing and making sure that things are well written, as opposed to, I don't know, like making sure you have the right amount of, making sure you have tabs in the right places or something, so. Any other questions? Yeah.
You mentioned earlier how this model or this harnesses helps the models, their code output to be better, especially when they're sandbox, right? What do you think usually, let me rephrase it. What difference would it be between giving itself a sandbox versus running in my machine apart from security? Do you think it's because they're already used to being sandbox?
No, I don't think there's a huge difference. It's the kind of tools that it's expecting, right? It's expecting to be in a bash environment. And so if you say, here's something interesting. So a lot of the products or like features that are coming into products that are around AI, they're kind of built around giving the AI more access to more tools. So tools aren't a sandbox, though. The model isn't trained very well, and maybe a little bit, maybe they train it on tools a little bit, but they train it really like on one tool, which is Bash. So if you're working on a feature that like involves, having an LLM do something, you have a couple of routes that are, well, you have a few options. The one that's like the most common is just, giving it access to tools that say, hey, get this thing, hey, delete this thing. That one's going to be the worst performing one. Then you have at the other end of the spectrum where you can give the LLM access to a full sandbox. That's going to be the best results because that's how it was fine-tuned. And then slightly behind that one is like giving it access to like a fake sandbox, which is like, there's a project in JavaScript called Just Bash, and it's not actual Bash, but it's pretending to be Bash. And for the agent doesn't care, it just sees like a tool call that it can call, and it sees a file system that it can act on, and it's like pretty much there, right? So back to the question of like, is it going to perform better in a sandbox? Like, if the sandbox is Bash, yes. If the sandbox is calling tools, then no, it's not going to do it's going to do okay. It's not going to do as good as well as if it was in, a Bash sandbox. So, cool. More questions? Okay, thanks guys.